Hello everyone, welcome to Critical Thinking with Ruth Suarez. Today we have chosen a couple of math problems that we will be working on, and I will be helping you solve them as well as telling you why we got the answer we got. But before we begin, a little light humor. So, have you ever heard of the mathematical plant? I heard it's got squared roots. Sorry. Anyway, I just like to lighten up the mood because whatever we're going to be talking about today, it's kind of, might kind of throw you off. But fret not, I am here to help you. So first of all, we are going to start by seeing these problems. So, critical thinking. So the first one says, complete the following puzzles. And here we have, place the digits 8, 10, 11, 12, and 13 in the circles to make the sums across and vertically equal 31. Is there more than one answer to the puzzle? Show all possible combinations of numbers to prove how many combinations exist which meet the rule of 31. So you see right here that we have 1, 2, 3, 4, 5 blank little circles. So what I did was use guess and check by adding. So in order to see where our little circles and where our numbers are going to be in the circles, I tried placing them in the examples down here as 12 plus 10 plus 13 going from up to bottom. And then across, I put 8 plus 10 plus 11. So we see that the one across, 8 plus 10 plus 11, gave us 37. So it's not 31, so let's move on to the other one. And vertically, I put 12 plus 10 plus 13, which equals 35. So neither of those answers are correct, so we cannot use them in the little circles provided right here. We see that neither equals 31, so we try again by rearranging the additions. So right here we put 13 plus 8 plus 12, which equals 33. So it's not correct, but it's pretty close. 2 more down and it would be 31. Then we have 11 plus 12 plus 13, which equals 36. Also not quite right. So we try again by using smaller numbers. So we use 8 plus 13 plus 10, and that gives us 31. So that is correct. Then we use 13 plus 11 plus 8, which equals 32, so not quite there. So we choose another one, 12 plus 8 plus 11, which in return gives us 31. We see that 8 plus 13 plus 10 and 12 plus 8 plus 11 works, so we use it. We ask ourselves, what do these additions have in common? Because remember, we have to put them vertically and horizontally in a cross. So we see that the numbers that they have in common is 8. So we use that. They both have 8 in common. Since we see that there is 3 circles vertically and 3 across, and they have 1 circle in common, we assume that it is 8. So we put 8 in the middle. We then see how many times we can arrange and still equal to 31. So in example number 1, we put 12, 8, 11, making sure that 8 is in the middle. We go across, which is 10 plus 8 plus 13. Then, since we see that gives us both 31, we go to the next example, which is 10, 8, 13, 12, 8, and 11. So we have another combination here. Then we move to a third one, which is going to be 13 plus 8 plus 10 going vertically, and 11 plus 8 plus 12 horizontally. Then we see another combination. We're not done yet. So then we see the other combination is 11 plus 8 plus 12 vertically, and horizontally is 13 plus 8 plus 10. So we see that we have 4 combinations. On the first diagram, the numbers in the small circles are found by adding the 2 big ones adjacent to them. This is another problem. This is letter B. So we use addition. So right here, this is an example that's going to help us solve for other ones similar to this one. I don't know if you can see. Let's see. I wish I could zoom in to that one. Actually, I think I can. There you go. You can kind of see it. It's 2 here, 8 on the other side, then 3, and then 5 is the one on the bottom left. So then we add these numbers together. We use 2 plus 8, which in return give us 10 for the middle one. Then we go clockwise. Then we use 8 plus 3, which is going to give us 11. Sorry, I skipped all the way to the bottom one. Then we're going to use 5 plus 3, which is going to give us 8, right in the bottom one. Then on the left side, we have 2 plus 5, which is 7. So that is how we see that that's solved. Alrighty. In the next one, following that example, we solve the following problems. In number 1 here, we have 15, 12, 20, and 17. And then we have 4 circles, which in the circles provided are the numbers that we need that added together are going to give us the numbers we get in the middle. So since we already have number 7, we start there. So what we do here is we subtract 7 off 15 because that is how the opposite of adding, which gives us 8. So we add the 8 on the other circle. We can then subtract 8 off 20, which gives us 12. We then continue to subtract 12 off 17, which gives us 5. Finally, we add 7 plus 5, which gives us 12, proving our answers are right. So right here, you see another problem. Right here in the bottom, we have 13, 11, 21, and 19 in the very bottom. So we have to find the same thing that we did in our example number 1 up here in the top of the page. So what we do here is we start clockwise again, but this time we do it, we only have 6 on the top right corner. So we go 21 minus 6, which is 15. Then 19 minus 15 equals 4, which we put on the little circle on the left bottom corner. And then 11 minus 4 is going to give us 7. And then 7 plus 6, we see that gives us 13, proving that the numbers that we plugged into our circles are correct. Now we move to a different problem. Number 2, it says, 9 square tiles are laid out on a table so that they make a solid pattern. Each tile must touch at least one other tile along an entire edge. See the 2 examples on the right. The squares all have sides of length which equals 1. So in example number 1, let me see if I can, oops. We can make it bigger. See, in example number 1 here, we arrange these squares with the blue one. First of all, we arrange it this way, which we are going to sketch all possible figures which can be formed and calculated the parameters of each figure that can be formed. Okay, so we see here that, let's see. Oh my goodness. we see in example number 1 that we have this blue one, a pink one, and a yellow one. So the only thing about this is that they all equal 16, unfortunately, because we see that the two, starting with the blue one on the top left, under example number 1, we see that the first little, it has 1, 2, 3, 4, 5, 6, 7, 8, 9 little cubes. So we find this how many units, I guess you can call it, because it doesn't have any inches or anything. So how many units are in the top part? So it is 1, 2. So 2 on the very top. Then we go to the side. How many is on the side? 1, 2, 3, 4, 5, 6. So there's 6 on this side, on the right side. Then on the bottom, there is 2 again. Then on the left side, there is also 1, 2, 3, 4, 5, 6. So 6 plus 2 is 8, plus 6 plus 2 is 8, and then 8 plus 8 is 16. Then we move on to the pink one on the top. So then it is how many just units, I guess we're going to say, are in the top part. So we see 1, 2, 3, 3 units, I guess. Then there's 1, 2, 3, 4, 5 units on the right side. And on the bottom, there is 1, 2, 3. So there's 3 again. And then on the left side, there's 1, 2, 3, 4, 5 again. So 5 plus 3 is 8. And 5 plus 3 is 8. So 8 plus 8 is 16 again. So we're trying to find different shapes that are going to give us different numbers, not the exact same numbers, because, you know, to find the perimeter, you have to add all the sides of the squares that are showing. And unfortunately, you know, you see the different shapes can still have the same perimeter. So then we move on to the one that looks like a straw, the blue one that looks like a straw. That's what I like to think it is. So we see that the top part, on the very top, is 1 unit. And then we check on the right side, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 units on the right side. Then on the bottom, there's 1 unit. And then on the left side, there's also 9 units because it's the same as the right side. So 1 plus 9 is 10, and then 1 plus 9 is 10. So then we add those together, which give us 20. Then, well, that one's a different shape and also a different perimeter. So we're on a good track. So then we rearrange it again, and you see the pink one over next to the straw. There is 1, 2 on the top, 2 units on the top. That is how many sides are showing. And then there is on the right side, 1, 2, 3, 4, 5. Then on the bottom, there's also 2. And we already know that the sides showing on the left are going to be 1, 2, 3, 4, 5. So 5 and 2. So 5 plus 2 is 7. Plus 5 again is 12. Plus 2 is 14. So the perimeter for the pink one is 14. Then we go ahead and we rearrange it one more time, which leads us to the one next to the pink one, which is yellow. I wish I had a little pointer so that you guys could see. Then we see that it is how many units on the top part. There is 1, 2, 3, 4, 5. So there's 5 on the very top. Then we see how many are on its right side. So how many sides are showing? 1, 2, 3, 4. So there's only 4 sides showing. Then we see how many are on the left side. 1, 2, 3, 4. So there's 4 on the left side. And on the bottom there is 1, 2, 3, 4, 5. So there's 5 again. Sorry, that's changed again. So there's 5 and 1, 2, 3, 4. 5 plus 4 is 9. Plus 5 plus 4 is 9, which gives us 18. So then we rearranged it again, which leads us to the pink one under the yellow one, which is the perimeter of 16. And how do we get that? We do exactly the same steps we followed on the other two. So this one is going to be 1, 2, 3, 4, 5. 5 are showing on the top, and on the right side, again, 1, 2, 3, 3 on the right side, and on the bottom side, 1, 2, 3, 4, 5. So there's 5 on the bottom, and 1, 2, 3 on the side. So 5 plus 3 is 16. Well, 5 plus 3 is 8, plus 5 plus 3 is 8. So 8 plus 8 is 16. So we get another one that equals 16. So we're kind of tired of the 16 showing up again. So we rearranged it one last time, and we get here 1, 2, 3 on the top, the yellow square. That's the one we're working on. So there's 1, 2, 3 on the top, 1, 2, 3 on the side, 1, 2, 3 on the bottom, 1, 2, 3 on the left side. So what do? We add them all together. 1, 2, 3 plus 1, 2, 3 plus 1, 2, 3 plus 1, 2, 3 plus 1, 2, 3, which is 3 times 4. I guess you can do it that way as well if you don't want to add too much. It's going to give us 12. And that is how we find how many figures we can do. So then there's a question, which has the least perimeter, which has the greatest perimeter? So the answer is going to be 1, because the yellow square has a perimeter of 12, which is the least greatest. And then the longest one, I guess, the perimeter, is going to be the one that looks like a straw. I just laid it down here, the pink one that you see, because the 1 by 9, 2 would have the greatest perimeter because it has a perimeter of 20. So that is how you find those answers. Sorry, my mouth is getting really dry from talking so much. All right, so now we continue to our next problem, which actually we are trying to figure out. Sorry. All right, so now here we have problem number 3, which says, show all possible solutions for the 2 following puzzles. A, if one must always move upward or to the right on the grid shown below, draw a diagram for each possible path from A to B. So what do we have here? We look at this graph, and there is our letter A, very, very tiny, going all the way up to B. So number 1, if you must take A right steps and B up steps, then the number of routes is simply where to take the right steps up or right. So value at the origin, which is A, is 1. For all other nodes, the value is the sum of its bottom and left neighbors. So right here we see that on the left, where our A is, the line going, our vertical line where our A is, we put 1, 1, and 1. And then on where our A is, our vertical line following it going the right way. On the right, we put 1, 1, and 1. So what do we do then? Let me see if I can enlarge this a little so that you guys can see a little bit better. Okay, so then now we see this right here, what we do, you see the little lines that I've created and put inside each square. So we add the bottom, where our A is like on the neighbor of our A to the right side. There's a 1 there. Then we add it plus the 1 that is directly above where A starts, which 1 plus 1 is going to give us 2. Then, since we already have on that whole vertical line, we all have a bunch of 1s, we add that by 2, which then gives us 3. Then we add 3 plus 1, which gives us 4. Then, following that, since we already have the 2, we continue on our next line where our rectangles are. So then what we do is, since we already have 2, we already have 2 plus 1 is 3, then we add 3 plus, actually, let me see. Since we already have 3, then we say, well, what do we get right here on this side? See, 1 plus 2 is going to give us 3, continuing on our second line, going from the bottom to the top. And so we see 1 plus 2 is going to give us 3. Then, since we already have 3, we already have 1 in the very bottom, in the very first bottom line, we add that 1 plus the 3 that we just got, and it gives us 4. So that is the second line. So then we go to the third line, going from the bottom to the top, from left to right. Since we already have 1 and we already have 2, we see that 1 plus 2 is 3. Then keep going towards the right, since we already have that 3, and we already have the 3 on the bottom of our second line, we add 3 plus 3, which then gives us the 6 that we have right there. Then 6 plus the 4 that we already had in the bottom of the right side, we get 6 plus 4 is 10. Then we continue on our 1, 2, 3, 4th line, going from left to the right. So how did we get this 4? Well, we did 1. So for all the knots is the sum of its bottom, which is right underneath 4. You see the 3, and the left of it. So 1. So 1 plus 3 is 4. Then we say, what is 4 plus 6? It is 10. Then we add 10 plus 10, which is 20. And that is exactly why, therefore there are 20 paths from A to B, because we just added all of those to equal 20. Now that's kind of complicated, sorry about that. So B, if one must follow along the paths of the following diagram in the direction of the arrows, draw each possible path from C to E. Number 1, we see that the direction of the arrows and see where they are leading. So right here, we see this whole diagram right here, which is C, then it leads to A, that leads to B, that then leads to E. So we're supposed to get from C to E. So here are a few examples of how many directions and arrows we can use. All right. All right, so we see the examples. So number 1 here, we see that it goes from C to A, which then goes to B, then it goes to E. So that is one way. The second way is C to B to E. The third way is C to F to E. Then the fourth way is C to F to B to E. Therefore, there are 4 possible paths from C to E. I recommend that you use, well, I know that maybe you probably wouldn't want to draw it, but if you have a chalkboard or a whiteboard, you can do it that way. Or you can do it how I did it here, which I just drew in over and over again, and that is how you get all your possible paths. So there's that. All right. And the next one. Let me try to zoom this in for you all so that you can read it along with me. Okay, it says, the figure to the right shows an additional pyramid in which each number is the sum of the 2 numbers immediately below. For each of the incomplete addition pyramids, show that the values in each square can be determined by forming and solving an equation in the unknown variable shown. Write an equation to solve each pyramid. Show each step used to solve each equation. So first, we see the example of a full pyramid right here, which is 17, then there's 8 to the left, and 9 to the right. Then underneath that, there is 3 to the left, 5 in the middle, and 4. So that is how, in order to find the top number, you must find what two numbers added equal 17. Then you must find what two numbers added together equal 8 and what equal 9. Using three numbers, find one that is added to another to equal 8 and a third that added by the second equals 9. So we're going to be sharing the third number. So what number is going to give us the two numbers that we have in the second, in the pyramid with the two squares? So then we see that 8 plus 9 equals 17. And I put the little arrow down there just so you can see just kind of like a little pyramid so that it makes a little bit more sense. 3 plus 5 on the bottom of 8 is going to equal 8. And 5 plus 4 is going to give us 9. So we know that we're supposed to share the 5. And that is how you come up with the pyramid. So now here are some examples that are kind of missing a few numbers. So with the given information, we know that we need to find the two numbers that equal 25. Talking about letter A right here. We have 7 and 3, which added together gives us one of the two numbers we need, which is 7 plus 3 is going to give us 10. So directly above 7 and 3, we put 10. All right, now that we have 10, we can subtract it from 25. So then we are going to subtract 10 off of 25 to give us the one next to the 10. So fill in the left square right underneath 25. So 25 minus 10 is going to give us 15. So now we have 15 on the left bottom under 25. Now that we have all the other numbers, we can find x. So now we subtract 15 minus 7 because that is directly above, and that gives us x, which is going to equal to 8. 15 minus 7 is 8. So there you go. Now we have 25 in the very first top one, then 15 on the bottom left, and 10 on the right. Then we have 8 underneath 15, 7 in the middle, and 3 on the left bottom. And that is how you solve for your pyramid. Then there's letter B. How do we find that? Okay, so let's begin the same exact way, which I know it's a little bit different, but in this case, we use guess and check. That is what I chose to do that. So we see that 15 minus 6 is 9. We just used 6. We just picked a random number, which is 9. Okay, so then 9 plus 6, because we already put the 6 in there, it's going to equal 15. So, okay, that gives us the right one, right? So 6 and 9. Then we'd say, okay, 6 minus 2 gives us 4. And that is incorrect. And then we use 9 minus 1, which equals 8, which is also wrong because those two together do not equal y whenever the third number that you're going to need. So these two, 4 and 8, are not the same number. If they were the same number, that would be correct. But since it isn't, it is incorrect. So then we try 15 minus 8. So we just kind of toss away the first one that we started plugging in. So we try it with 8. So 8 minus 15 is going to give us 17. I mean, not 17, my bad, 7. So then that would be the other number that goes on the left or right underneath 15. So then we say, okay, well, 8 plus 7 is 15, so that's good. Those two numbers are good, looking good. But now we have to find the y, and that's going to be tricky. So 7 minus 1 is going to give us 6. All right. And then we continue with the one on the right. 8 minus 2 is going to give us 6. So since these two gave us 6, we decide that y is going to be 6. So now you see that your pyramid is going to look like this. 15 on the top, 7, 8, 1, 6, and 2. And that is exactly how, when adding from the bottom to the top, it's going to give us 15. So that is how you're going to do that one. Then we still have a couple more because we got to find how to solve each section. You know, we are going to keep using guess and check because that is my favorite thing to use for these. Using the previous examples, solve. So then we have the numbers already provided, 27, then z, then 2 and 9. So we are missing the z, then we are missing the right one, and then the middle number. So we use guess and check again. We do exactly the same thing that we did for the other ones. We decide to use 9. Okay, so 13 minus 9. So we're trying to find, we just choose a random number, so we choose 13. And so we subtracted minus 9, which is our bottom number, which is going to give us 4. And so we're like, all right, it's going to give us a number. Nice, nice, okay. So then we use the same 4, and then we add it plus 2. And we say, well, it's going to give us 6. All right, that's pretty good. So now the moment of truth comes, which we added 13. 13 plus 6 is 19. So that's not right. Then we do, okay, well, let's try 15. So we do 15 minus 9, and we get 6. All right. Then we use 6 plus 2, which equals 8. But 8 plus 15 gives us 23. So, I mean, even though we're closer, it is not exactly 27. So we're like, all right, well, we're going to toss these two out. So let me try again. We use 17 now. 17 minus 9, which is our bottom number, it's going to give us 8. All right, which is the other number. And then 8 plus 2 is 10. Okay, then we do 10 plus 17, which gives us 27. So now we see that 17 goes on the right, on the bottom of 27. 10 goes on the bottom left of 27. Then underneath 10 is 2 and 8. And which number do they share? Oh, it's 8. They share 8 because 8 plus 9 is 17. And 2 plus 8 is 10. 10 plus 17 is 27. And that is how we solve that problem. Now we go to our number 5. This one's a little bit different. This is more of a, I find these are actually one of my favorite ones because it's just kind of fun. It gives like, I feel like a detective trying to figure out the little details and having to kind of assume, you know, that's my favorite thing to do. So the word problem says, 4 married couples belong to a bride club. The wives' names are Kitty, Sarah, Josie, and Ann. Their husbands' names, in some order, they're not saying the exact order they are David, Will, Gus, and Floyd. Use the table to sort out who is married to whom. So first of all, we get this little nice convenient table. This is the information that we know. So it says, Floyd is Josie's brother. All right, so Floyd and Josie can't be together. Then there is Josie and Gus dated, but then Gus met his wife. Okay, so we know that Josie cannot be with Floyd or Gus because first it would be incestuous, and the second one, well, it didn't work out. So then Kitty is married to Will. So we already have one couple that we know is married. So, all right, so how are we going to use this information? Okay, Anne has 2 brothers. All right, cool. And Anne's husband is an only child. So then we know that Josie and Floyd are not. Gus and Josie are not. And Kitty and Will are. So now, what do we do? All right, so then we have this table here. So pretend this is not. Okay, so what do we know? We know that Gus and Josie are not. So we put an X. Number 15, we put an X. All right. We know that Floyd and Josie also aren't married because they are siblings. So then there are 2 left. There's 3 and 7 left. Pretend like that X is not there. I'm just showing you how to solve it. So we have 3 and 7. All right, so we leave those right there. Okay, cool. So that means these 2 are not together. All right. We know that Kitty and Will are married. So then we just put a little nice check on number 5 because under Kitty, because we already know that. So it can't be David, Floyd, or Gus. So that already know that Gus and that Kitty and Josie aren't Gus's wife. So we're like, okay, guy, what are we gonna do? All right. So then after that, we see the other information that we do know, which is Anne's husband is an only child. So that means that that Anne can't be married to Lloyd because he has a sister and he's not an only child. And also, she can't be married to Will because that would be polygamy, and that is not right because he's already married to Kitty, because we already know that. So it can't be Floyd or Will. So who else do we have? We have David and Gus. So how are we going to find that that Gus is Anne's husband? All right, so we continue. So we already have X's on that. And then we use Will. Well, Josie can't be married to that guy because, yeah. So what else do we see? Anne has 2 brothers. So let me see. So then we put an X on David. So then that leaves us with Gus. So now we have Anne and Kitty's husband. So now we need Sarah, which, let me see. All right. All right, so since we know that for Anne anyway, for Anne we mark Floyd off because, well, it says here that Anne's husband is an only child, so he has a sister, so that automatically marks him out. We also know it can't be Will because Will and Kitty are married, so we write an X where Will is. That leaves David and Gus. So how do we find that? Since Josie isn't married to Will because Kitty is, we mark him out. Floyd is, well, that's her brother, so no, we mark him off. And Gus isn't either because they dated and then he met his wife, so we mark him off. So now Josie is only David, so we put a little check on the line where David is. So then we automatically know that David isn't going to be Anne's husband or Sarah's or Kitty because Kitty is a married woman. So we mark every other man off her list. So now we have Sarah by herself. And so since we already marked off David because he's married to Josie, we mark David off Sarah's list. Then we know that Will is married to Kitty, so we mark him off Sarah's list. Floyd, well, he's the blank one. Then Gus is married to Anne, so we mark him off. So then that leaves Sarah and Floyd as a couple. So there you go. Kitty and Will, Sarah and Floyd, Josie and David, Anne and Gus. So that is how we find the 4 couples. Next up, is number 6. So what do we do here? Let's read the instructions. All right, it says, consider the trapezoidal numbers 1 plus 1 plus 1, 1 plus 2 plus 2 plus 2 plus 1, 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1. The nth trapezoidal number is 1 plus 2 plus blank plus n plus n plus n plus blank plus 2 plus 1, where n is a positive integer. The dot pattern that represents the trapezoidal numbers is 1 plus 1 plus 1 is 3, 1 plus 2 plus 2 plus 2 plus 1 is 8, and 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1 is 15, as follows. So then we write the little dots on the bottom. So we write, first of all, we have 1, 2, 3 dots by themselves, since we are following the trapezoidal numbers. We're supposed to draw a trapezoid. So then, all right, so we add on the bottom of those 3 dots, we add 1, 2, 3, 4, 5. So then we add 5. After that, we add another row underneath that one. 1, 2, 3, 4, 5, 6, 7. So we're just kind of adding as it goes. We add 2 at a time. So then after that, we add 1, 2, 3, 4, 5, 6, 7, 8, 9. Likewise, we can plot any trapezoidal number by using this pattern. Notice on number B, it says, notice that 1 plus 1 plus 1 equals 1 times 3. And then 1 plus 2 plus 2 plus 2 plus 1 is 2 times 4. And 1 plus 2 plus 3 plus 3 plus 3 plus 2 plus 1 is 3 times 5. Show how the dots in the representation of a trapezoidal number can be rearranged into a rectangle with 2 or more columns than rows. So then we add the 3. Then after that, we add 2 on the sides. Well, we add 4. And then we add a little red one. That's how we keep adding them. So then we add 3, and then on the, you see the little, the little dots here represent the ones that we are adding using number 7. It says, how do you find the nth trapezoidal number? Like, how do you use the inductive reasoning? Then we find that n, parentheses n plus 2, is the solution. And that is how we find our number. All right, I hope today my lesson kind of help you guys understand how we find the answers. I hope this helped, and I hope you come back again. Give it a thumbs up.